Hello everyone, we are Group 10 of Division P. Our COA assignment topic is Division Restoring Algorithm. So I'm roll number 58 and I'm gonna start with the introduction part. So we all know what division is, right? It is a mathematical operation that gives a question and a remainder. We will see the hardware implementation of the division algorithm in computer architecture. So we use registers and counters while performing division. Now let's start with seeing the types of division algorithm in computer architecture. Types of division algorithms. Division algorithms in computer architecture is of two categories. The first one is slow division. In the slow division, we get one digit of the question every iteration. The algorithms for slow division category are restoring, non-performing restoring, non-restoring, and SRT. The second category is the fast division. In this method, the question is predicted to the closest approximation with the actual question and then the calculation starts. The algorithms for fast division category are Newton-Raphson and Goldsmith. So here we will discuss the restoring division algorithm in computer architecture for unsigned and signed integers.
This is roll number 53. I will cover restoring division algorithm for unsigned integer. Restoring division is usually performed on the fixed point fractional numbers. When we perform division operations on two numbers, the division algorithm will give us two things, that is quotient and remainder. This algorithm is based on the assumption that 0 is less than d and denominator and that is less than numerator. With the help of digits set 0 and 1, the quotient digit q will be formed in the restoring division algorithm. The division algorithm is generally of two types, that is fast algorithm and slow algorithm. Goldsmith and Newton-Raphson are the types of fast division algorithm, and STR algorithm, restoring algorithm, non-performing algorithm, and there are a lot of types of slow division algorithm. In this section we are going to perform restoring algorithm with the help of an unsigned integer. We are using restoring term because we know that the value of register A will be restored after each iteration. We will also try to solve this problem using the flowchart and apply bit operation. Thank you.
I am roll number 57 and I am going to continue about the flowchart of restoring division roots algorithm. Here is the accumulator, M is the divisor, Q is the dividend, and N is the number of bits. So in the initialization, the value of A, which is always taken as 0, and the value of Q are shifted left as by considering them as a single unit AQ. Then the binary value of M is subtracted from A and the result is stored in A. At the next step, the MSB, that is the most significant bit of A, is checked. If it is 0, then LSB, that is the least significant bit of Q, is set to 1. Otherwise, if it is 1, then LSB of Q is set to 0 and the value A is restored. For the next step, we have to decrement the value of N by 1. If the value of N becomes 0, then go to the next step. Otherwise, repeat the steps by left shift the value of A and Q. For the last step, the binary value of Q register as a quotient and the binary value of A register as a remainder. Hence, we complete the flowchart. I am roll number 57 and I am going to continue about the flowchart of restoring division roots algorithm. Here is the accumulator, M is the divisor, Q is the dividend, and N is the number of bits. So in the initialization, the value of A, which is always taken as 0, and the value of Q are shifted left as by considering them as a single unit AQ. Then the binary value of M is subtracted from A and the result is stored in A. At the next step, the MSB, that is the most significant bit of A, is checked. If it is 0, then LSB, that is the least significant bit of Q, is set to 1. Otherwise, if it is 1, then LSB of Q is set to 0 and the value A is restored. For the next step, we have to decrement the value of N by 1. If the value of N becomes 0, then go to the next step. Otherwise, repeat the steps by left shift the value of A and Q. For the last step, the binary value of Q register as a quotient and the binary value of A register as a remainder. Hence, we complete the flowchart.
Roll number 54. Now let's see an example of restoring division algorithm. Here we have taken 7 as a dividend and 3 as a divisor. So initialize the value first. Next step is to perform shift left. So this MSB of Q comes into LSB of A and LSB of A is 0. After performing shift left, subtract M from A. So the result is 1101. Now MSB bit of A is 1, which indicates negative. So we are supposed to restore value of A. So the result is 0011. After restoring, we get the value of a is 0. Next, again shift the left and then subtract. We are getting 1110. Sign bit of a is 1. So restored value a equal to a plus 1. So we are getting back same the value of q is 1100 is there, and sequence counter is decrement from 3 to 2. After this, again shift left because it is not equal to 0. After performing shift left, subtract m from a. So here sign bit of a is 0. Now what we will do, set the value of q not to be 1 and decrement the counter value is 1. Then shift left again and subtract. We are getting 1110. Now if you see the sign bit again 1, so restore the value. So after this, the value of q naught will be remaining 0 and decrement the counter, it becomes 0. So because of counter is 0, stop the process. So what happens at the end, q holds the quotient and a holds the remainder. So q is 0011 0.
I am roll number 55. Now let's take a look at restoring algorithm for sign integers. The restoring division algorithm in computer architecture is almost identical from both sign and unsigned integers. For sign integers, we will take the bit representing the magnitude of both the numbers, and at the end we put the sign with the quotient. Everything else remains the same. The advantages of restoring division will explain by 56. So the advantages of non-restoring division over the restoring division are as follows. In the restoring division method, the quotient is represented using a non-reduction number system. This is a paper and pencil usual algorithm. Its main characteristic is the full bit comparisons required to reduce the new quotient digit. Restoring division algorithm is very similar to manually performing long division. Non-restoring division algorithm, that is NRDA, comes from the restoring division. The restoring algorithm calculates the remainder by successively subtracting the shifted denominator from the numerator until the remainder is in the appropriate range. The operation in each step depends on the result of the previous step. Non-restoring division has a quotient digit set of 1 to -1 instead of the conventional binary digit. The advantage of using non-restoring arithmetic over the standard restoring division is that a test subtraction is not required. The sign bit determines whether an addition or subtraction is used.
So it was all about division restoring algorithm. Thank you for watching.